Okay, who can tell me the rules for adding and subtracting fractions in a nutshell, which means like in the fewest words possible? Aubrey? So that's just for fractions. Who can give me one rule that kind of covers both fractions and decimals? You're getting more specific right now. Addie? They have to be comparable. Okay, to add and subtract fractions and decimals, the numbers have to be comparable. Now that looks different between fractions and decimals. Aubrey, for fractions, what does it mean if they are comparable? The denominators have to be the same. What does that look like as decimals, Hutley? Okay, but to be comparable for decimals, they have to have the same number of decimal places, okay? But I'm trying to simplify the rules for you so you don't have so many rules to remember. So to add and subtract fractions and decimals, they must be comparable, okay? Because we've talked a lot about what does it look like for these things to be comparable. So let me see where we are at. Let's go to this one right here. 2/5 plus 1/10. Make it bigger for us. To add and subtract fractions, the fractions must be comparable. Are those two fractions comparable? No. Why, Bryson? Yeah, for fractions to be comparable, the denominators must be the same. Is there something I can do to make them be the same, Kinley? Yeah, so I can make this one have a denominator of 10. So let's show we want that denominator to be 10. That one's going to stay the same. And Kinley's saying to turn a 5 into a 10, I can do 2 times that. If I multiply the 5 by 2, what else has to be multiplied by 2, Gabe?
You have to multiply times the same thing times
the numerator. Yes, the numerator. What you do to the denominator, you also have to do to the numerator. So now we have 4/10 plus 1/10. Now that the denominators are the same, how do I add two fractions that are already comparable?
You just take 4 plus 1.
Okay, what is 4 plus 1? 5. What's my denominator? 10. What should you always ask yourself once you get an answer, Elise? Yeah, is this the best answer? When you're asking yourself that, you're looking for two different things. Who can tell me one thing? When I say, is this the best answer, what's one thing I'm looking for? Lainey?
If you can multiply it anymore or simplify it.
Simplify it anymore, which usually to simplify, we divide the top and bottom by the same thing. Okay, so we're saying, can this be reduced or simplified? Hutley? Is it a proper or improper? Which ones do we have to fix? Improper we change to mixed. Okay, 5 and 10, is there a number that I can divide 5 and 10 by, McKay? What's the number that goes into 5 and 10? 5, so I can reduce them both by 5. Divided by 5, divided by 5, 1/2. Final best answer. Okay, I want you to go do the next one. I want you to try the next one on your own. It's very similar. In the next row, let me get there. That's not it. That one, very similar. You're first trying to get them to be comparable. Do you have a question? So on this one, did anybody change the denominator to 16? No one did? Could we have? Yeah, so why is it better to just change the 2 to an 8 instead of changing them both to 16? Huntley, what do you think?
If you want to get to 16, it's longer, and you want the smallest.
Yeah, so we could change these denominators. We could create equivalent fractions that any number that 8 and 2 both go into. So we could do 16, we could do 24, we could do 32. We could change it to that, but we're trying to keep our life simple. So the simplest problems are when the fractions, the denominators are already the same. Those are our favorite because we don't have to do any work. The second kind of medium problems are where we have to change one of the denominators, where one of the denominators I can multiply it by something to make it equal the other one. Okay, that's what this one is. But we could always, if you can't think of a common denominator, what will always work? If you can't think of anything else, what could you always do? Aiden? Not 10. 8 doesn't go into 10. Elise?
1.
Not 1. Ava? Not 2. It's not a single number every time. It's you can always multiply them together. Okay, whatever your two denominators are, you could always multiply them together, because if you multiply them together, that means they both go into that number. Okay, so if you're trying to find a common denominator, if one doesn't just jump out at you, you can always multiply the two numbers together. Okay, that will always work. Now, when we get 11/8, what should I ask myself, Augie? Is that the best answer? When I'm asking myself, is that my best answer, what am I looking for? Okay, is it improper and can it be reduced? Is it yes to either of those? It's improper. How do I fix it?
Go over to the side, do 8 divided by 11.
11 divided by 8.
11 divided by 8. 8 goes into 11 once.
Okay. And then my remainder is my numerator. Denominator stays the same. So 1 and 3/8. Okay, let's look over next to it. Can I turn a 3 into a 10?
No.
No, so this is one where I'm going to have to change both of them. Gabe, what is a number that 3 and 10 both go into? 30. Could I have done 60? Could I have done 90? Yeah, but again, and Gabe kind of did the trick I just said. If you can't think of one, you can always multiply them together. What's 10 times 3? 30. So let's change them both to 30. Are we magicians? Can we just magically make that 10 turn into a 30? No, we are mathematicians. So we can make it turn into a 30. We just have to apply some math to make that happen. Clara, what do I have to do to 7/10 to make the denominator 30? Multiply it by 3, so I have to do it to the numerator and the denominator. Kinley, what do I have to do to 3 to make it 30? Times 10 times 10. Braylon, how do I add those two fractions now that they're comparable? Okay, what's 21 plus 10? So we have 31 30ths. Lexi, what am I asking myself? Oh, is this my best answer? And I'm seeing, is it improper or can it be reduced? Either one of those? Okay, which one? It can be, it's improper, so we can change it to a mixed number. So I'm going to come out here to side. 31 divided by 30. I don't know. How many times does 30 go into 31? Once. What's left? 1 left over. So 1 and 1/30th. Final answer. I want you to try the next one. We'll see. No, it's still recording. So I want you guys to go over and try the next one. Aiden, you working on this one? Addie B, what did you come up with as the common denominator? 35. Do you guys agree with her? Yes? Did anybody use something besides 35? Who can tell me something we could have used? If we didn't use 35, it just would have made our life harder. You can do multiples of 35. So what's 35 plus 35? 70. So we could have used 70. We could have used 105, 140. But do we want to work with numbers that big if we don't have to? Nope. So, Aliyah, how do I turn a 7 into a 35 using math? Times 5. Times 5. What's 5 times 5, Aliyah? 25. On the other side, Emily, how do I turn a 5 into a 35? Times 7 times 7, so that's 21. 25 plus 21, Carter? We get 46 over 35. Addie J, is that our best answer? When I change it to a mixed number, what do we get? 1 and 11 35. Good job. 1 and 11 35ths. Okay, not so bad, right? Okay, let's go over to the adding decimals over on the right. And again, fractions you guys did last year more. Decimals we don't have as much practice with. Which ones have we haven't done that one.
19.5.
Okay. Did we already do this one?
Yes.
Okay. 19.5 plus 16.45. When we're lining these up, what do we have to remember? Hutley. Okay, they have to have the same number of decimal places. There's something else that's important. Lainey?
You have to make sure your decimals are lined up.
Line up the decimal points. Okay, we do that first. When I'm deciding which one's going to go on top of my addition sentence, Kinley, what do I look for?
The bigger one,
What do you mean by bigger one?
the greater decimal.
The greater whole number. Okay, so you're not looking at decimal places. It's not the longer one goes on top. It's the one that has the greater whole number. So we're really just looking at 19 and 16. Ava, what's bigger, 19 or 16? 19. So I'm going to put 19.5 on top. I'm going to put 16.45 on bottom. This is an addition sentence. Now, tonight on your homework, you have a mixture of addition and subtraction. What do you think the biggest mistake is going to be when we grade these tomorrow, Gabe?
People not putting the decimal point.
No, there will be some of that, but the biggest mistake is going to be a goofy one.
They're going to forget the invisible 0.
Nope. Aliyah?
They're gonna keep doing adding.
Yes, some of you are going to add on all of them, even though you know that a minus sign means subtract. So be aware of that when you're working and they're kind of mixed together. It's not like add, 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 subtract, subtract, subtract. It might be like add, subtract, 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 add, subtract. Okay, you have to pay attention to those little symbols because they're important. Okay, now to add this one, someone kind of already said what we need to do there. We need to add a 0 to make them the same number of decimal places. Carter, what do I do with my decimal point? Straight down into my answer, and then I add like normal. 0 plus 5 is 5. What's 5 plus 4? Anybody? 9. 9 plus 6? 15. Regroup. 3. Rewrite our answer so we know this is our answer. Make sure your decimal point isn't a speck. If you guys are peckers, I see a lot of people do this. They just peck their paper with their pencil. Can you see it? No, it doesn't even show up. So darken in your decimal point just to make it show. Don't just peck your paper with your pencil. Okay? What's weird about the next one? MK? Yeah, there's a number without a decimal point. So now we got to turn on our brain. If I have a whole number 3, we don't need the decimal point. That's why we don't put it there. But where is it? If I needed it, Gabe, where is it?
Like invisible kind
It is invisible, but I need it now. I need to see it. So where will I put it?
of? Right behind the 3.
Right behind it, because is 3 the same thing as 3.0?
Yes.
Yes. Is it the same as 3.000?
Yes.
Or 3.0000000, as many zeros as I need? Yes. So if it's a whole number, we have to put it in. I'm going to go ahead and write this one under it. How many more zeros do I need to add? Bryson? 2 more. 1, 2. We bring our decimal point straight down into the answer. Now I just do my math. 6, 5, 4, 5. 5, dark decimal point. Okay, and always turn off your math brain, turn on your common sense brain. The whole numbers here are 3 plus 2. What is 3 plus 2? 5. If people miss this one, they do their addition right. They line stuff up funky, or they put their decimal point in the wrong spot. Is 5 point something close to 5? Yeah, it's between 5 and 6 is our answer, which makes sense. Okay, I want you to try the last one. 3 of them. Do we know how to add 3 numbers all at the same time?
Yes.
Yes, you just line up the decimal points, do it exactly how you would before. Now, I reordered mine. Raise your hand if you didn't reorder them, but you got the same answer. Okay, so do you have to reorder it? No, it just makes it, I like to do the greatest number to the least number. But when you're adding decimals, you make them to where they're all the same number of decimal places. The only time it gets kind of confusing is if like your whole numbers, if that one's a single digit whole number and this one's like 3-digit whole numbers. If we're not super neat in our handwriting, which think to yourself, am I super neat in my handwriting? Some of you guys answer yes to that. Some of you answer no. The ones who answered no to that, that's where you might struggle, is if there's whole numbers that are different amounts of digits is where that would be beneficial. Okay, questions on those? Okay, flip it to the back. Throw in some subtraction. We're going to skip some of these because I want you to have some time to start on your homework. On the back, on the subtracting, let's go ahead and do 7/8 minus 1/2. Why can I not currently... Oh, yes. Yep. Why can't I currently subtract these two fractions? Emma? Yeah, they're not the same denominator, which means they are not comparable. What can I turn both of those denominators into? Into an 8, yep. So this one is going to stay 7/8 minus, I want this one to be an 8, so we do times 4, times 4, 4 times 1 is 4. Now that I have a common denominator, Kinley, what do we do? Okay, what is 7 minus 4? 3, and my denominator stays the same. 3/8. Best answer, why? Can't be reduced, and it's not Improper. I like subtracting fractions more than I like adding them because usually there's less at the end. There's less finishing. Okay, now here are the ones. I'm just going to go down from here because mine's right here. These are the ones where kids are like, can't do it. Why does their brain say can't do it yet? Can't do it yet. Lainey?
Because 12 is a big number.
No, not because of the 12.
Because once you multiply it,
Shh.
once you do it to you get it to 9, 12, so they just say 0, 0.
Okay.
They just say
Okay, we're not there yet. You're planning ahead. Carter? So people look at the numerators because they know I'm going to have to subtract my numerators, and they see 3 minus 9, and they're like, can't do it. And you shouldn't say can't do it. You should say can't do it yet because we haven't learned negatives. But we can do it because we don't look at the numerators until what? Hutley? The denominators are the same, okay? So a common wrong answer there, they'll give me like 6 and then a random denominator. Okay, because they do 9 minus 3 instead of 3 minus 9. Can we switch the order of subtraction? No, so they break all kinds of math laws to give me crazy answers. That's why I want to point them out. But Gabe was correct. We have to get the denominators the same first. So he's saying we can get them both to 12. So that one's going to stay. Gabe, how do we turn a 4 into a 12?
times 3.
So times 3 times 3. Elia, what's 3 times 3? 9. Now, I'm going to point this out because I saw it a lot on the fractions as division worksheet. I had people give me answers of like 0 twelfths. It's just 0. And here's an example as I'll give you a division problem because our fractions division. Okay, if Ava has $0, okay, and she is so generous, she is going to share all of her money with 12 people. Isn't that nice of her? She can. How much does each of them get? 0, because she has nothing to share. So 0 twelfths isn't the best answer. 0 is the best answer. Okay? And you can also think anything minus itself is always 0. 5 minus 5 is 0. 3 minus 3 is 0. 9 twelfths minus 9 twelfths is also 0. I'm going to move on from fractions because I think you guys have a lot more background in that. Let's go to the decimals. I have noticed when you are subtracting on your long division, if there is regrouping, some of us are struggling with the regrouping. Okay, so when we get to regrouping ones, I'm going to slow down. Can we change the order in subtraction? No, you cannot. So these ones, we don't have to think. We just line up the decimal points. 17.25. I always put my decimal point first so I can make sure I line them up. I highly suggest you write that subtraction sign. Okay, without that subtraction sign, you can still know to subtract, but if you write it, you're more likely to subtract than add. Because I'm telling you now, some of you tomorrow, you will get the wrong answer because you will add when you're supposed to subtract. Can I start doing my subtraction yet? No. Aubrey E., what do I need to add before I can subtract? Okay, I should say, what do I need to add in before I need to add 1 0 right there to make them comparable, same number of decimal points. I'm going to drop my decimal point into the answer. Now we just do our subtraction. Elise, what's 5 minus 0?
5.
There we go. Bryson, what's 2 minus 2? 0. 7 minus 9. Hutley?
You can't do it, so you have to take 1 from the.
Yeah, we have to regroup, so we mark it out there. Here's what I suggest, just add it in right there. Okay, some of you like to mark out the 7 and write it above it. That's fine, just make sure you write 17, not 16 is a common error. What is 17 minus 9? 8. So our answer is 8.05. And again, turn off your math brain, turn on your common sense brain, focus on the whole number. 17 minus 9 is what? 8. So my answer should be something close to 8. Is 8.05 close to 8? Yes. Okay. So one more to the right of that. 68 minus 8.45. What do I have to think about for this one, Braylon?
You have to see if they have the same amount of numbers.
Of decimal places. Why is that weird on this one? Lainey?
Because 68 doesn't have a decimal at all.
68 doesn't have any decimal places at all that I can see. Where is my decimal point in 68 if I can't see it?
It's right behind this.
Right behind it. So when I set it up, I'm going to write 68. I'm going to go ahead and just add in my decimal point because I know where it's at. I don't need to add zeros yet because I'll have to figure out how many I need. Subtract. This is a regrouping one that a lot of us struggle with. How many zeros do I need to add? 2. A lot of people will give me an answer of 60.45, which is incorrect because we have to regroup. Can I take 5 away from nothing? No. Usually you go to the next column, but there's nothing there. So I have to go here, and I'm going to take this step by step just to refresh your memory on what's happening here. We borrow 1 whole from there. What's that 8 going to turn into? A 7. And really, it goes here. It goes there, but why did I have to do that, Emma Kay? Why did I take it there? Okay, when you regroup, you really only pull it over 1 column. Okay, but we had to pull that one over to that column so that what? Addie? Yeah, so now I have something in that column to steal from for the hundredths column. Okay, so I'm taking it step by step so you can see. So now I have 10 there, but I have to take 1 away so it can get all the way over to there. Okay, I think we forget that process and we get going too quickly and make goofy mistakes. What is 10 minus 5? 5. 9 minus 4? Decimal point straight down. 7 minus 8? Got to regroup. 17 minus 8? And then 5 minus nothing. So 59.55. Okay, I want you to take a second and try the next 2 on your own. Try the next 2 on your own. If you get stuck, look up. I'll try and show as much work as possible. Once you finish, look up, check your answers. If you missed it and can't figure out why, raise your hand and I will come help you. any questions on these ones? We good? Okay, let's do the last one. I saved this one. This is a hard one because there's lots of regrouping. Jackson, you should have it. We started it on Tuesday. It's the notes page from Tuesday. When I see a whole number and I'm adding or subtracting decimals to it, what should I add in? What do I have to add in, Carter? A decimal point. Okay, then I'm going to put the 45 under it. 1, 2, 3. How many zeros do I need, Emily? 3. Why will people mess up on this one? Emma? Yeah, there's 4 zeros in a row, which means this is why I did this. We got to practice our regrouping process. I think you guys get going sometimes, so slashing and changing numbers. You don't fully process what you're even doing. It's more of just like a routine, and that's when you make goofy mistakes. So, oops, I did put a plus sign. That's a goofy mistake too, isn't it? Red, let me add my zeros back in. Okay, so now when we regroup, I cannot take 3 away from 0. So I look at the hundredths place, nothing there. Tenths place, nothing there. Ones place, nothing there. So I have to go all the way to the tens place to regroup. When I take away 110, that gives me how many ones? When I take away 110, how many ones is that? 10. So now I have 10 ones. But does that solve my problem?
No.
No. I have to take away 1. Now I have 9 ones, but that gives me 10 tenths. Does that solve my problem yet?
No.
Got to keep going through that process. Take 1 away, I have 9, now I have 10. Take 1 away, that has 9, now I have 10. So typically when you go over lots of columns and they're all zeros, most of them turn into what? Nines. But I just want to make sure you remember why they turned into nines. Okay, what is 10 minus 3? 7. 9 minus 2?
7.
So now our work's pretty easy. 9 minus 1?
8.
Decimal point. 9 minus 5? 4 minus 4?
0.
And 1. Now, common sense, brain. 150 minus about 50 should be close to 100. Is 104 close to 100? If you had $104, could you say I have about $100? Yes. Oh, I put 3 sevens. Another goofy mistake. Okay, I have a worksheet to pass out. While I'm passing out the worksheet, I want you to get out a piece of loose leaf. Okay, I'm passing out a worksheet. You need loose leaf. Okay, listen up so you don't do too many problems, because again, there's lots of them on this worksheet. So I want you to turn the side that is all decimals. Turn to the side that is all decimals. Okay, the reason I had you get out loose leaf is because you are going to work all of your homework tonight on loose leaf. Okay, because they don't give us a ton of space to work it on here, and I know some of us don't have the neatest handwriting, so when we try and squeeze it, we make goofy mistakes. Okay, so I'm making you do all of your homework on what? Loose leaf. If when you're finished, if you want to write the answers to them on your worksheet so it's easier for you to check tomorrow, that's fine. Okay? So on the decimal side, how they're kind of numbered by letters, how there's like A, B, C, and D. Everybody see that? Under the D line, let me get a highlighter here. Under the D line, I want you to draw a highlighter mark all the way across between both sets of problems. So like over on this side, there's another A, B, C, D. Then over on the side, I want you to write Thursday. Do not mark off the bottom ones because we will end up completing this worksheet, just not today. So above that line is what you will be doing tonight on this side. Okay, now that is 4, 8, 12, 16 problems. Okay, but some of them are the ones where we don't have much work to do at all. Flip it to the back side where we're looking at fractions. On the fraction side, this one's where it's going to get funny on marking it, okay? On the one on the left side where it says fraction B at the top, see how there's 3 problems on the top row? And then there's 3 on the second row. On the top row, it's like problems 1, 5, and 9. On the second row, it's problems 2, 6, and 10. I want you to take your highlighter and just mark it like that. So how many fraction problems do you have on the left side? 5. Okay, and it's not 1, 2, 3, 4, 5. You're doing the top row and then 2 from the next row. Okay, and then on the right side, it's the same thing. You're doing 1, 5, 9, and then 2 and 6. So on that one, your box will kind of look funky too. So that it is 26 problems altogether, okay? But some of them, there's very little work to do at all, okay? Some of them will be a little bit longer. I want you to go ahead and get started on it. Are you doing any of your work on the worksheet? Nope, we're doing it all on loose leaf. My suggestion is label, because there's like 2 number 2s, 3 number 3s. Whichever one you're starting on, if you're starting on the one that says adding and subtraction fractions B, I would write fractions B on your loose leaf so you know what problems that goes with, okay? Because really that worksheet is 4 worksheets kind of all mashed together. Questions? It's kind of confusing.